So we're starting our introduction to proofs, and we need to do some basic just definitions in order for you to be able to figure out exactly what proofs are. So starting with the definition of the word definition. A definition is a precise or an exact statement of the qualities of an idea, object, or process. So that's actually what a definition is. It's got to be exact. Now, a postulate, if we were to define that, a postulate is going to be a statement that is assumed to be true without proof. In geometry, the whole concept of proofs is getting you from one statement to another and using definitions and postulates and other things to prove those things to be true. And postulates are something that you don't actually have to prove. Another word for postulate is an axiom. So those are synonyms. An example of a postulate or an axiom would be that a line segment can be drawn between any 2 points. So that means if I showed 2 random points, I could draw a line that would connect them, and that would be called a line segment. And we don't have to do anything to actually verify that is in fact true because we know it's true, so it doesn't need to be proven. Moving on to the next page. A theorem is a statement that has been deductively proven and can be used as a reason in future proofs. So it has already been proven, and we can use it now in proofs. A corollary is a statement that is very obviously or easily deduced from a theorem. It can also be used as a reason in a proof. For example, if there was a theorem that said that equilateral triangles have 3 equal angles. Well, we know there's 180 degrees in a triangle, so we could easily deduce that each angle is 60. So a corollary would be that in an equilateral triangle, each angle is 60 degrees. And then the next blank is the word axiomatic. The axiomatic method, that's just a big fancy word, allows you to prove or disprove conjectures by using logic based on definitions and postulates. When we draw proofs, when we write proofs, we list, this is what they look like. This is called a 2-column proof. That is a definition of a 2-column proof. On the left side, you have statements, which are the things you're claiming to be true. And on the right side, you have the reasons, or how you know that they're true. The first thing you have, though, is that what your given is. And the given is the fact that you're given. You must assume that it's true. And then what you list here, the prove part, is what you want to prove to be true. The left side is a series of deductions to get you from point A to point B. And the right side states your reasons for the deductions. You have to have proof of why you think those things are true. And QED is written after the last step to show that the proof is done. That's just something you just write. It's not anything big or fancy. It's just what you write. Okay. Moving on to indirect proofs. When you try to prove something indirectly, that means you kind of want to go in, you're not just going to straight up prove that it's true. You're going to kind of go in a weird way to do that. So you start with assuming the opposite of what you want to prove is true. And you use deductions to prove that the opposite is actually false. And this contradiction proves that the original statement is in fact true. So we have 3 steps to prove things. The first is that we use definitions, postulates, or axioms, because they're the same thing, and common notions to prove a statement is true. A statement is now a theorem. Once we prove it to be true, it becomes a theorem, and that's something that's always true. And we use theorems to prove corollaries and other statements. So if we were trying to define a theorem, the easiest way, we've already talked about the official definition, but if we were trying to put it in our own words, we would probably say something that it is a statement that has been proven true. That's all a theorem is. It's a statement that has been proven true. And a corollary is a statement that makes sense based on a theorem. So if we wanted to try and prove that a car driving east means that none of the cars are facing west, well, we would start with, if a car is driving east, that means that the car is facing east. And the reason we know that is that a car drives the direction it's facing. That makes sense. The car drives the direction it's facing. The second statement they've given us is that all the cars are facing east. Well, and if you think about it, that would be true because any car that's like all in the same lane, they're all facing the same direction. Like you don't have cars in the same lane that are going opposite directions. So we could say that cars in one lane, cars in a lane, all face the same direction. Well, from that, we can then figure out, well, if all the cars are facing the same direction, they're all facing east, so none of them are facing west. And that's also true because cars can't face 2 directions at one time. Okay, so we have down here, we're supposed to create a flowchart proof to show, okay, notice this is important. A flowchart proof looks like this, because there's going to be a question on your quiz about that. This is what a flowchart proof looks like. It's got boxes and arrows. The one above us, right here, this is also a flowchart proof. It consists of boxes and arrows. So if we wanted to prove that chickens will not provide milk, well, we've been given some statements. We know that chickens have feathers, no hair, and lay eggs. All mammals have hair and produce milk. And then we know that some mammals lay eggs. So in the first box, we've got to start with what we know. We know the Macy has chickens. And in the last box, we always end with what we're trying to prove. We're trying to prove that they're not going to give us milk. So chickens equals no milk. So now we have to figure out how to get from the fact that Macy has chickens to the fact that her chickens aren't going to give her milk. So let's see what we know. Well, we know that chickens have feathers, no hair, and lay eggs. All mammals have hair and produce milk. So we know that if they have to have hair, and that all mammals have hair and produce milk, but chickens don't have hair, then that can be our next statement, is that chickens have no hair. And if the chickens have no hair, then the chickens are not mammals. And if the chickens are not mammals, then they can't lay eggs. If we talk about why, well, we know the first thing is our given. Macy has chickens, we're told that. How do we know the chickens have no hair? Because we know the definition of chickens. We know what they are composed of. And then how do we know that that Macy's chickens are not mammals? Well, we know that because they have no hair. And the reason we know that they can't produce milk is because only mammals produce milk. And we've already said that the chickens are not mammals. A few other things you may want to take notes on is, what are the things that don't require proof? There's several things. Well, number one, postulates. That was in the definition of postulates. And that also includes axioms, because axioms is another word for postulates. Common notions are also things that do not require proofs. They were vaguely mentioned at one point in the notes, but not really talked about. So that's why I wanted to make sure you saw those. It's also good to remember that an indirect proof is the same thing, or is also known as, I'll put AKA, a proof by contradiction. They are the same thing. I would make sure to have those things written down because they'll be beneficial to you on your quiz.